Hi, I'm Adam from Forgotten Studios, and in this video we're going to look at some basic concepts of the Forgotten Waveshaper 2. The Forgotten Waveshaper 2 is based around this idea of waveshape modules, which are going to be your distortion algorithms. You can have up to 8 individual waveshape modules, and a waveshape module consists of two parts. You have the waveshape display to the left and some modifiers to the right. The waveshape display is the main way you're going to design your distortion algorithm and change its sound. You can add points and you can change curves between the points. You have 3 sections that modify the waveshape itself, and 3 of 4 sections that don't really affect the waveshape itself, but affect the sound of the waveshape module. So anyway, the curve morpher lets you morph between different curve types. The curve bender lets you change the intensity or curvature of the curves. And the shift knob lets you change the horizontal or vertical position of the points. Below that, you have the timbre knob, which lets you control the amount of high frequencies in your signal. Because a lot of the time when you're distorting a signal, you might want to tame down the amount of high frequencies you get. So you can attenuate them by 20 dB or boost them by up to 10 dB. To the right, you have the dynamic section, which it doesn't really change the waveshape itself, but it changes the way it reacts to the signal. If I turn it on, you can see these lines that represent the threshold. And when the signal crosses the threshold, it's going to distort, and when it's below the threshold, it's going to stay clean. Or you can invert it by using the invert switch here. But if you'd like to know more about what the dynamic section does, I recommend checking out the video on creating custom compression and limiting algorithms, or read the manual, it's all written in there. So below you have the input gain, and that's really useful because a lot of the time the signal might be too quiet or too loud, so you can adjust it to get to the sweet spot of the waveshape. Because the way a waveshape is driven by the input signal greatly determines its sound. To the right, you have the pan knob, which I'm not going to go what that does now. I think it's explained in the video called processing modes. And to the right, you have a wet gain to adjust the gain of the wet signal only. Use this to loudness match. And then you have the dry wet knob to inject some dry signal into the wet signal. And finally, you have the output gain to adjust the volume of the whole waveshape module. Okay, so we have one waveshape module for now. And it's not going to do anything on its own. You can add more waveshape modules, but they're not going to process anything. You first have to tell them which signal to process. So at the moment, we just have one frequency band and with 2 slots, so I can pop it into the first slot. And if you'd like to know what these slots do, I think it's also explained in the video about processing modes. But if it's not, you can check out the manual on that. But just populate the first slot first. I recommend that. So now it's going to process this frequency band with this waveshape module. Okay, yeah. Like that. It's maybe a bit extreme. Let's change. Let's use this distortion. Okay. This is not. Yeah, it's a nice sounding distortion, but you can do much more. You can add more frequency bands to make the device a multi-band distortion device. And actually, the cool thing is you're not limited to using a different waveshape module here for the second frequency band. You can also use the same waveshape module twice. So this frequency band is now processed by this waveshape module, and this frequency band is also processed by the same waveshape module. And you might think that this does not change the sound, but actually it does change the sound a lot, as you can hear in a moment. Let's just add some more frequency bands and assign the waveshape. You can hear how the attack of the guitar really cuts through. And if I remove frequency bands, it's going to get more and more mushy and more one sound. And this is because of this phenomenon called intermodulation distortion. So when you're distorting a signal, you're not only going to get the harmonics of the individual frequencies in your signal, but also sums and differences of these frequencies. So guitar has multiple frequencies, of course, happening at the same time, and you're not only going to get the harmonics of these individual frequencies, but also like stuff in the middle that's not harmonically related to the harmonics. So it's like mudding up the sound and creating a lot of trash. This is similar to aliasing, which also creates harmonics that are not related to the input frequencies. But that's a digital phenomenon, and intermodulation distortion also happens in the analog domain. But it's also the sound we're used to when distorting, because in the analog domain, creating a multiband divide is, it's not so easy. So yeah, you can have the same waveshape module, or you can have a different waveshape module. For example, I can have some clipping distortion on the top band, and our usual, what was this? I think it was analog saturation, yeah, in the bottom band. So yeah, that's it for this video. I hope you liked it, and have a nice day.